Hi guys, ako nga pala ulit si Ramil Magbuo from IT2102 and today I'm here in the front of you to discuss what are the comparison of the differences between the OSI and the TCP models. Now, let's get started. Na this is the four layer of TCP models and the comparison and differences between the TCP or the IP and OSI models. And this is the also in encapsulations and encapsulations. So, like OSI network model, TCP IP also has a network model. TCP or the IP was on the path of the development when the OSI standard was published and there was interaction between the designers of the OSI and TCP standards. The TCP model is not same as the OSI model because the OSI is a 7-layered standard, but the TCP or the IP is the 4-layered standard. The OSI model has been very influential in the growth and development of the TCP and the IP standard, and that's why much OSI terminology is applied to TCP. The following figure compares the TCP and the IP and OSI network models. This is the comparison between the 7-layer and the 4-layer of the TCP models. As we can see from the above figure, the presentation and session layer are not there in TCP models. Also note that the network access layer in TCP or the IP models combine the functions of the data link layer and physical layer. So, in layer 4, this is the application layer. It is the topmost layer of 4-layer in the TCP model. So, application layer is represented on the top of the transport layer, and application layer defines the TCP and application protocols and how host programs interface with transport layer services to use the network. In layer 3 also, in the transport layer, this is the transport layer. So, it is the third layer of the 4-layer TCP model. So, the position of the transport layer is between the application layer and the internet layer. The purpose of the transport layer is to permit device and the source and destination host to carry on a conversation. Transport layer defines the level of services and status of the connection used when transporting the data. In layer 2, the internet protocol or the internet layer is this in TCP. So, the internet layer is the second layer of the 4-layer TCP IP model. The position of the internet layer is between the network access and the transport layer. Internet access or internet layer pack data into data packets known as the IP datagrams, which contain source and destination address and information that is used to forward the datagrams between hosts and across networks. The internet layer is also responsible for routing IP datagrams. So, this is the layer 1 or the last. It is the network access layer. It is the first layer of the 4-layer TCP or the IP model. Network access layer defines detail of how much data is physically sent through the network, including how bits are electrically or optically signaled by hardware devices that interface directly with the network medium, such as coaxial cable, optical fiber, or twisted pair copper wire. So, The most popular LAN architecture or the most protocol included in network access layers are Ethernet, Token Ring, and FDDI. So, an access method determines how the host will place data on the medium. Every host has equal access to the medium, and then it can place data on the wire whether when the wire is free from network traffic. When a host wants to place data on when the host displays data on the wire, it will check the wire to find whether the another host is already using the medium. And then the traffic already in the medium, the host will wait if there is no traffic. It will place the data in the medium. But if the two systems place data on the medium at the same time, or the instance, they will collide with each other, destroying the data. If the data is destroyed during the transmissions, the data will need to be transmitted. After all, the collisions is a host will wait for a small interval of time and again the data will be retransmitted. In this lesson, you have learned about the 4 layers of TCP model and the comparison between the 7-layered OSI model. Now we're going to have a TCP and the data encapsulation and the decapsulation. In encapsulations, when data moves from the upper layer to lower level of TCP or the protocol stack, each layer includes a bundle of relevant information called a header along with the actual data. The data package containing the header and the data from the upper layer uh, then then becomes the data that is repacked at the next lower level with the lower layer's header. Header is the supplemental data placed at the beginning of the block of the data when it is transmitted. The supplemental data is used to receiving the decide to extract the data from the encapsulated data packets. These packets of data at each layer is known as the data encapsulation. So, we're going to have the encapsulation. It is the reverse process of encapsulation. It is occurs when the data is received on the destination computer as the data moves up from the lower layer to the upper layer of the TCP or the IP protocol stack. Each layer unpacks the corresponding header and uses the information contained in the header to deliver the packets to the exact network application waiting for the data. This is the names of network data packets. The transport layer, uh, here in example shown. Mhm. This is the names of different network data packets. The format of the data packets generated at different layers is different. And also known that the application layer is known as the message. Application layer message is again encapsulated at the transport layer. The data packets at the network access layer which encapsulate and may subdivided the IP at datagram is known as the frame. The frame is converted into the byte stream at the lowest sublayer of the network access layer and then placed on the medium. So, in structure of the internet frame, the data packets from internet layers move to the network access layer as it moves down to the protocol stack. There are sizes limitation for internet frames. And then, we have the MAC address, And it is the last. Thank you. Now, thank you for watching and for my video. I hope you learn about something in my reading, and God bless.